all the training for Juniper is free. So unlike Cisco training with certifications and whatnot, where you have to pay, Juniper training, you can set up an account on juniper.net and you can enroll in any of their classes and get their certifications with minimal cost for the training. You still have to pay for the test, but the training is free. Whether you take the test or not, it's up to you.
They still go based off of that test.
For the certifications? Yeah, so certifications are an important way to prove to employers that you have a competency level. You know, it's not necessarily like required. So what I'm doing now is I'm gonna set up my laptop, put it on the display. Then we're gonna do an initial power on, show you guys the boot process of this, and I'll take you through some of the more basics of it. I'm not gonna go into a full-on config tonight. I'm just gonna introduce you to the CLI of Juniper, how it works, some of the ins and outs of how to set things in there as opposed to Cisco. We can do Cisco at another time. Do you have any questions yet?
Are the difficulty levels between the two?
You gotta know, so networking fundamentals are agnostic to vendor. So as long as you know your networking fundamentals, you can work on either platform, then it's just a matter of syntax. Okay, so before I even plug it in, let me hook up this so you guys can see what's going on.
You probably need to join the Zoom from there.
What's that?
You probably need to join the Zoom from there as well.
Join the Zoom on this one?
Yeah.
I put the link on the chat.
Every time I see this guy, he's eating. What'd you get tonight?
That's a surprise. What's that?
Blackface.
Do we pass
What'd
that
you
around
get?
as well?
Blackface.
Pass that around
Where?
as well.
Blackface.
Oh, I don't know that place.
You haven't tried it?
No.
You should try it.
It's good?
Yeah.
Yeah, the chicken's really good.
Yeah.
It's a
What
lot.
place is it?
Blackface, it's like
Blackface.
nearby. Like
It's off Camino and Federal.
yeah, like
Okay.
15 minutes.
A lot.
Yeah, it's a lot.
Oh, it's halal?
Turkish people, yeah.
No way.
Yeah.
Oh, dear.
Okay, so the first thing I'm gonna hook up here, so this is a
My Muslim friend, brother. Yeah.
This is a console cable. How many people are familiar with the console cable concept? So I have another console cable over there. This is a USB 3 one. So it's got like that round plug on it. Like newer USB plug, right? Because my laptop doesn't take this old plug. This is also a console cable I'm thinking of. And what this is a basically like an Ethernet cable in essence. If you take a look at it, most of the time, this one's an end-to-end, so there's no turning on this one. The turning happens here. This is a RJ45 to DB9 serial adapter. That's what this is. And this would go into your serial port of your laptop. Some of your older laptops would still have a serial port, or your old PC might have one. And then these things hook up via COM port to connect. So this goes into there, this goes into your computer, this side goes into the console there. Newer technology operates with this device here, this little USB-C. So the whole adapter thing is packed into this little thing. There are other modular type adapters that go to the older form of USB too. These are fairly new and they work fairly okay. You said join on this one, right?
Yeah, the link's on the Discord.
I can smell that from here.
They hit me too at the same time. Hello.
Turkish people know what they're doing, right? Yeah, they know what they're doing apparently.
I have a friend who opened one up down in Fort Lauderdale.
Oh, there's one, yeah.
He's
Yeah,
from
but-
Turkey. He opened one up though.
It was good. I got like a little like big box of like chicken. It was like chicken, fries, and
You should try the mango carbonara slider.
You opened
Yeah,
up
I
like
think I might
that.
have slided instead.
Yeah.
Like, I feel like that little like title was just too much stuff.
Yeah, that is too
Your excitement is getting me anxious to try this place, bro.
It's good.
It's got a new camera system.
Yep.
Jump
Pretty
scare.
good.
It looked really good.
There have been times I go there at 1:30, it closes at 2 a.m. in the night.
No way. They close that late?
Yeah.
Oh man, that's dope. Okay.
Dude, it's a lot. It's the Florida version of halal card.
Yeah. This looks really good though. Looks
I
fire.
asked my friend, I'm like, how do you even find this out?
Yeah.
I don't know if you met, his name's Fareed. He's
Okay,
in, like,
so everybody can
class.
see my screen now.
Yeah.
Yes. So what I have here. Let me screw this up a little bit. Is I have a terminal emulator. This one here is called Van Dyke software. It's kind of like Putty, but on steroids. It's a professional software to do this. And some of the things that you want to know about with regard to COM ports, find under session options. Okay, so you can see there is that the COM port is a USB serial port. It has a baud rate. So the baud rate is 9600. That's kind of standard for most networking gear, not all.
What does that mean?
So that's the amount of data that can flow through the cable back and forth over the serial. Serial connection is going to be very slow compared to Ethernet. So the baud rate must match the device in order for it to work. Without the baud rate matching, you will not get any characters there. If you change that to another number, it won't work. Now, typically, if you encounter a networking device from another vendor, some oddball networking device, some of the newer ones, they'll set the baud rate to like 115 or 38,000. And those are all selectable through here. There's specific rates. You see them? So I've seen network gear at 38,400 and I've seen network gear at 115,200. I don't really see the other ones when it comes to networking gear. So typically you want, the rule is for Cisco and most Juniper is what they call 9600 8 none 1. So 9600 is your baud rate, your data bits is 8, your parity is none, and your stop bit is 1. So you hear that term 9600 8 none 1, you know what the settings are supposed to be when you open up a putty for a serial connection. Okay. Other things to consider when you're dealing with terminal emulation is something known as rollback buffer. So this is how far will this buffer, screen buffer, go before it starts to overwrite itself. So I typically like to set this to like a very high number, like 5,000 or 10,000. So we've set that, we're ready to go. We're gonna juice this thing with some power. And then we should be able to connect to the serial. And it's pretty noiseless because this is a tiny little system. And we're connected and we're already getting our prompt. So at this point during the boot up, it's like any other computer. Okay, it's going through its post, finding hard drives, it's finding memory blocks, it's finding ports, doing its standard stuff. You can see it says hit any button to stop auto boot. There are what we'll call password recovery sequences for hardware that are usually executed during this post that will allow you to reset the password on the device. So what that means is, like, for any network device, if I have physical access to the network device, I can put a serial cable in there and do a possible key sequence during boot up to enter a sub menu that'll allow me to do like a factory reset. On this type of device, there's a pin in the front that says reset. You just put a paper clip in there and then hold it while you boot up and it'll factory reset. One of the things you're going to see with Juniper when it comes up, it's going to list as amnesiac. Amnesiac basically means like I've lost my memory. And it's basically meaning it's default. So nothing has been written to the drive and it doesn't know about anything. So it's thinking like I've been, hypnotized and I know nothing. So that's what amnesiac is. So it's giving you some base information there, on how it's booting up, and I'm gonna go for a little bit here. You guys can't see it, but I see. So one of the things is that the Linux box, this is a Linux box. Okay, so it's running a Linux operating system that you'll see flash up on the screen there. And it's a BSD. Okay. And you can enter into that BSD shell, and it's probably going to dump us into that shell initially. And we have to then initialize into the CLI. The CLI being the network environment. Now, because this is fancy terminal software, I have the ability to then open up like a network browsing session or this thing like a file explorer with another sub package of secure CRT called SecureFX. I'll show you guys how that works and how similar it looks to Linux. Once you open up the file system, you'll see all the standard Linux folders, the root, the var, the etc, the tmp, everything you normally see in Linux. Still not there yet.
Is it open BSD or free BSD?
I want to say it's possibly free. You can look that up. I never really cared to check. So it's doing some base, certificate signing generation stuff right out of the box. And there's a web GUI associated with this too. So you could plug an Ethernet port into one of the ports here. You would get DHCP and an address on your Ethernet port, and then you could web into web console rather than go through serial. So serial's for the pros. Okay, you know what you're doing when you're dealing with the serial console and you're consoling into the device. The web GUI, you don't have to be a professional to operate in a web GUI. You don't have to know the commands you want to execute. All you got to know is how to click the mouse. Because you can go through the menu, the web-based menu, and turn on and off features that you don't even know what they do. So we recommend that everybody learn the console method first with the command line method before you move into the GUI method. Because doing the GUI method, although it's easier, isn't as fruitful for your own base knowledge. You could end up really messing yourself up. So we're still booting. Okay, so as I said, Amnesiac is the terminal that's given us. I believe it's I'd probably look up what the default is. It's been a while. Might be admin, I'm not sure. Root with no password, so I was right. And what you see here is this prompt here. This is telling you what software is running on the system, and it's still there. I'm here. You can see I'm at root, but I'm in. This is the shell prompt. I'm not in the actual operating system. So my standard Linux commands will work here. So ls -la. Okay. Looks like Linux. I can even go cd space ... upper directory, go pwd, see what directory I'm in. I'm in the /cf directory. Go cd space ... ls. Now I'm in the directory above that. And this is, I wouldn't say, this might be the root directory. Yeah, so this is the top level tier directory that you're seeing there. And you can see you have the op, you have, data, there's a bin, There's a bunch of folders that look like Linux, and then there's some other folders that aren't Linux related, right? We're still not really able to work on this yet. Okay, you're just in like the subsystem underneath of the Juniper operating system. So I believe to enter it, you enter CLI, and now the prompt has changed. Okay, so if I do a show config, this is the configuration, okay? And this is a base configuration that comes with the device. Starts with an auto install feature, and then you can see there's some interfaces with the boot P, which is like DHCP. It's got some base name servers to go out and get DNS automatically if it was connected to the internet. Some services, so SSH, Telnet, and some other web management services. So this is enabled on these other ports here. So I can hit the web management via HTTP or HTTPS with system self-signed certificates over any of these ports 1 through 5. So 1 through 5, it has a DHCP pool set up automatically that will give you an address in the 192.168 area. That's what that reads there. And other DHCP pools based on what interfaces and stuff you're set up on. Now, understand that this is looking a lot like what? What does this code look like to you? With all the brackets and the spaces and the hierarchical structure. Does it not look like some type of computer coding? Like
C++?
like any type of computer coding, it looks like computer coding. And it operates like computer coding too. It's a hierarchical type CLI. So the furthest left position is a root level position. So security is a root level position. Syslog is not a root level position. Underneath syslog, all of these things are sub to syslog. Okay. And all of these things are sub to security, and so on and so on. So under security, you got screen. That's the actual firewall part of things. Okay. Now, why does it say screen? Does anybody know that? This is a trick question. Juniper did something that Cisco does. What does Cisco do? Does Cisco invent anything? Or what do they do? Rather than invent something, isn't it easier to buy something somebody else put together? So Juniper acquired another company that had security. That company was called NetScreen. And that's why it says screen here. Because they integrated the NetScreen OS into Juniper, gave it their own little flavor on top.
Can we increase the magnification on this one?
Sure.
You can, I mean, you can do from there, I guess.
Tell me when. Better? More? Yeah. So you can see screen up here. So that is about NetScreen. You can look up NetScreen as a company, used to be around, now they're part of Juniper. All right, so you have the NAT, we know what that is, right? Network address translation, we're familiar with that term. And then the way that these architecture for these firewall devices work is they work on zones. It's called zone management. You have, right now, there's built-in 2 zones. There's a trust zone and an untrust zone. Okay. So this pre-canned NAT says match anything from the trust zone and then NAT it through using this rule to the untrust zone. And then source NAT the interface that it's going at. Same thing with policies here. It says anything from the trust zone to the zone trust, allow, match any. So any direction, source address, any direction, destination address, any application, then permit. So the statement here is read from top to bottom. It executes the policy. When it finds a match, it executes. Does that make sense? Okay. Then here, from trust zone to untrust zone, match, source address any, destination address any, application any, then permit. That means anything from the inside can get to the outside. Okay. Now, here's where it gets tricky. Is it says zone, security zone, trust, host inbound traffic, system services, all protocols, all interfaces 1 through 5. And then the last part here, security zone untrust, untrust interface 0. So that's the first port on the box, 0, 0. Host inbound traffic, system services, DHCP, TFTP, that's all it lets through the first port. So what it's telling you basically is that the first port is hardware encoded right now to be the untrusted port. And then the rest of the ports on it are on the trust side. You can have multiple zones. I can have a trust zone, I can have a trust strong zone, a trust light zone, a trust heavy zone, a zero trust zone. You can make up more zones and put them in here. Each zone would have its own set of policies that would affect how the zone behaves. This is the physicality of the interfaces here. So you're at a top level for the interfaces. That's touching each of these physical configurations for each one of these. The way it works is that you have the interface name, unit name, and then there's something known as a family name. Okay, so 0 is, this is the 0, 0 port, doesn't have anything on it, it's unit 0, it's not configured, not set up yet, won't do anything yet. Okay. The interface on the inside, port 1, the first interface, is set up with unit 0 as well. Family is INET, which means internet or IP. And the address is already hard-coded in it of 192.168.1.1, which is the gateway of our DHCP. So when you get a computer and you hook it up to port 1, you'll get a DHCP of 192.168 something, and it will hit that hard routed layer 3 interface. Does everybody know what that means when it's a routed layer 3 interface? Okay, so interfaces can operate in multiple modes. In this case here, these are operating as a hard interface. That means that there is a IP address bound to that interface, and that's all that's on there. Okay, that's what we call a layer 3. Everybody's heard of the OSI model? What's the third layer of the OSI model? The network layer. So you go physical, data link, network. Network layer is where IP exists, right? That's where this exists. So your network layer makes it a layer 3 address that's hard-coded, bound to that physical interface. What if it was a layer 2 address or a data link layer? Now I'm passing what that's known as tags or VLANs. I would have multiple VLANs. I can have more than one VLAN, or I can have just one VLAN and operate at layer 2. Okay, so the switch port has the ability to operate at either layer 3 or layer 2. It's your call. This pre-canned setup that comes out of the box is set up so that you can connect to it and get to the web GUI. Okay, for a small office, 192.168 network is probably good enough. They would consider the outside and hook up their cable modem to port 0, and then start configuring rules to allow things to get out to the internet, into devices. Maybe you host a web server on port 5 and you set that up as an untrust or a semi-trust. You only allow HTTP to there. Those are all things that could be done with this type of box. Here's the rest of our interfaces, and you can see each interface is given its own subnet of DHCP pre-canned in there. Okay. So these are all set up as layer 3 interfaces, except for these last two that don't have any config, and those are the SFP ports. Those are the laser ports. That's the whole config on the box. Now, I'm going to show you one more time the configuration. And you can see how this is very annotated to read. And now I'm going to show you a way of altering this so that it's readable and how you would actually set it. So the way that Juniper works is set and no set or unset, or delete actually. So if I hit the question mark button here, I will get a base set of commands that can be run right here. So from here I have clear, which will clear the information on the system, configure. So like if I wanted to clear an ARP table, I did clear, ARP, whatever, you know. Configure, that's to enter into configuration mode. File is to copy files and move files. So if I have an existing configuration, I put it in USB, I can copy it from USB to the internal hard drive, okay, or load it into the operating system. Help, that's like your man pages type thing. Monitor is like your logging. mtrace is for multicast, as you can see there. OP for scripting, ping, quit, request, restart, and then you see set. Set is how you set things in the CLI. Now there's only a few things you can set at this level. The next level up to set things at is at the edit level. So in order to edit, enter into configuration mode, you have to type the word edit. Okay, and the prompt will change when I do that. And you have telnet, start, test, and traceroute. You know what traceroute is, everybody? You know what telnet is? And remember I said you can navigate to this thing. Let me see if I can do it here. Let me do it. So I'm going to try and open up a bridge between my local system. No, then let me do it. I probably have to configure it a little more before it lets me do this. But under normal circumstances on a fully configured system, when you connect to it via, let's say, SSH, you can then open this up and you would be able to browse the local file systems and directories, which is useful when you're trying to update the software. Now, under each of these commands is subcommands. If I type the word show and then put question mark, I get every command that can be run at show. Okay, and this is a lot of different things. You got to know what you're asking for. It's not just for the shy. Okay. And then each one of these things has sub-levels underneath that. We see words here that aren't even in the config, like OSPF and BGP and SNMP and all kinds of different things. One of the things to look at, if you wanted to look at the hardware, is to do show chassis, because it's referred to as a chassis. And then you can say, if you want to know what was available here, you hit question mark. But you could just type in show chassis hardware. And tab will autocomplete for you. You can do abbreviated commands too. So as long as it's not ambiguous of a command, it'll understand that you only typed a little bit of the command and it still takes it. So it's kind of like shorthand, we'll call it, or it's that thing they do in court, like stenography. It's kind of like that. Like if you know what you're doing, you can do this with the very, like when I normally type show, I don't put DOW. It's typically SH space, whatever. And then it automatically knows because there's only one command that starts with SH at that level to run show. And so the expression is that the less commands I type to do the same thing as you, the more valuable I am, because the less time I spend, the more time I can do things, the more valuable I am. So show chassis hardware shows you the actual physical hardware that you're dealing with here. It says this is an SRX 300. It's got an RE SRX 300, an FPC with 6x6, 2x2 SFP, and a base PIC. So all these things mean something. The RE stands for the routing engine, and that's the engine chips in here that do the routing functionality. On the bigger routers, the one we have in the back that runs the whole campus here, we run a Juniper, and it has two separate routing engine cards that are independent of everything you see, and they're just doing the routing engine. Then you have the FPC, that's the forward processing card. That's what the line card exists on, where these gigabit Ethernet and these SFP ports live. So now I'm going to introduce you guys to a concept that is a little abstract, but it's easy to understand if you just take a minute. The difference between a forwarding plane or an operating plane, a control plane, and a routing plane. So control plane and a data plane. Okay, so the control plane is where the routing engine exists. The routing engine decisions happen at the control plane. That's separate inside the architecture of the system than the forwarding processing, the FPC, the actual physical ports that are sending it in and out. Think of it as the FPC in that level is at layer 2, and the control plane or the forwarding plane, the routing plane is at layer 3. And so they're separated logically in the system, they're separated physically in the system through circuit architecture so that one operates without interfering with the other. That's why we have in the bigger chassis, we'll have routing cards, then we'll have what we call line cards or forwarding cards that the actual ports are on. So the instructions have two abilities when you deal with an architecture like that. One is that technology has evolved to the point where we can forward traffic without going to the control plane. Because we all know each other in here, we all had a ball in our hand. I had a ball and I wanted to throw it to you, I could just throw it to you. I don't have to ask where you are, right? We're on the same forwarding plane. Okay, I can see you, I can throw you the ball, you can throw the ball back to me. We don't even have to know about it. I can do like a no-look throw to him and he can do a no-look throw to me, okay? That's forwarding plane, and the forwarding plane builds forwarding tables. Those tables are based on MAC addresses. Sometimes it's called a CAM table. Okay, MAC address and CAM table are kind of like the same thing spelled backwards. Okay, so MAC address media access code, and the CAM table consists of a list of MAC addresses and their locations. So inside of these things, they have a CAM and a forwarding plane. So they establish when you power on the system and you plug these things in, you guys know what ARP broadcasts are, right? ARP broadcasts, ARP, Address Resolution Protocol, maps IP addresses to MAC addresses. Well, the MAC addresses have a MAC address table, right? We've heard of that one before. MAC address tables physically map MAC addresses to physical ports on the switch. So the switches, and if you think of just the physical FPC part of this architecture, the FPC operates like a switch where, unless it's layer 3 division hardware-wise, like you tell it here, where these have layer 3 addresses and they're hard set, they can see each other. So if I set them all to the same network in the configuration up here, and let's say I just set this one as the gateway, and these ones I didn't set anything, and I set them as layer 2, they would all be able to see each other like a hub. And inside the box, it would build a MAC address table, and when traffic tried to go from one host to another, it would just go. As long as it didn't get hit by any kind of policies up here that said you can't go, it would flow. And so that's internal guts of how these things work. Let me know if I'm losing anybody now. So now that's the FPC or the forwarding plane side of the business. Now the control plane side of the business is where the routing tables, the internet tables, your outside BGP and your OSPF tables, they all exist at the layer 3 level. That's the control plane. Why do we call it the control plane? It's because there's a lot of back-end business going on there that's making the box run. Why do we separate the control plane and the forwarding plane? This was not always the case. If someone overflows the forwarding plane with a broadcast storm, okay, like a DDoS attack, right? We're all familiar with those, okay? I don't lose access to the control plane, even though the forwarding plane's jacked, okay? Because if I did, he'd actually hurt me. So that separation allows you a layer of control. Now we have something known as COP, C-O-P-P, and that's COP. Sounds like what it really is, like we know what COPs are, right? COP is control plane policing. So there are, in some of the boxes, we have built in what they call control plane policing. And what that is to prevent anything in the physical layer one, layer two side from overrunning the memory of the box to affect the control plane's operation. So it will, when you're dealing with a network device like this, it's here to do one major thing. What's the thing that a firewall is here to do? Like any other network device, it's here to send traffic from point A to point B, source to destination. In this case here, it has what we call a filter, so it can filter traffic, so the only traffic that's allowed to get from A to B. But the forwarding plane, his job is to send packets. Separating that, the option for COP is when COP is in play and packets get oversent or flooded, or storms. COP has one option. It's the same option that football has when they're out of downs. They punt. So packets get punted. That means basically dropped. Okay. Now, each of these ports physically, am I going too deep for everybody? Have I lost everybody yet? Each of these ports physically has a buffer on it. Okay. What's the memory buffer for? Well, let's say all four of our computers are connected to a switch, and that switch is then connected to port 2. I start sending traffic, he starts calling up Netflix, he all of a sudden starts, doing something else. First off, how does the switch port decide who goes first? Well, in general rule of thumb, it's what we call FIFO. First in, first out. Okay. Doesn't have to be that way. And you can do QoS and some other mechanisms to prioritize certain types of traffic over others. But that buffer is there because as I'm calling up Netflix and he's calling up this, if we both hit enter at the same time, the thing has to be able to take a bunch of packets and then hold them in this very small amount of memory, let's say like 10 megs or 15 megs worth of traffic, as it's sending it through in millisecond level timing. So it's a very small buffer in each of the ports, okay? Now the difference between a data center grade device that you would use to pump traffic in the servers, where you get a lot of business going on, versus a single, what we like to call end loser computer, okay, is the end loser computer isn't going to overload that packet, doesn't need that big buffer. But in the data center, you need big buffers because everybody's hitting the same server at the same time. So they need to be able to hold enough of that traffic so it doesn't get punted. So the control plane is something, I wanted to go over the hardware so you understand the architecture of these boxes from an internals perspective. Each of the boxes has other things in it here, like you can look at the status of the routing engine, the temperature. You can show what's on the USB. Environment will give you some stuff. So if I do show chassis environment, you see that it's operating at 95 degrees and 122 degrees, and status is okay, and everything's fine. Power supply is 0. Nothing special there, but in bigger boxes, these things become relevant because you're passing more packets, more heat, more problems. Bigger boxes have bigger problems. So I told you I was going to show you a way to look at the configuration in a way that's not concatenated like coding. So there's a lot of things that we use to modify how we're inputting and outputting the command. So if I do a show configuration, and then this right here is called a pipe. Okay, that is the shift backspace key, backslash, or forward slash. Is it a forward slash if the bottom's going forward, or a backslash if the bottom's going forward? That's the backsplash, and the other one's a forward. You judge it by the top then.
Yeah.
You're a top judge. So pipe here, and then if I hit question mark, you'll see that I have a bunch of other things that I can do here. And one of the things that I'm going to do is I'm going to execute the display command. But this is a way of, let's call it, and if you know Linux, you've done pipe commands, possibly. Or even PowerShell has pipe commands, right? does it? Like you have command, pipe, and then some other command. So these are a subset of commands to help you modify your output or refine it. Okay? The display will show me the configuration that I'm asking for, whatever I'm asking for, display, and then I can say display set. Okay, so if I say display set. Now, this is what's set on the system. And notice it's just line by line of everything that we just saw without all that concatenation. If I copied this out and put it in Notepad, this is my config. I could literally just paste it back in there and it'll take it and reset it. I can also copy it out, change it, and then put it back in. I could also copy it out from a certain section. Remember I said that there's hierarchical sections? Security and interfaces and system are the three top level sections for this box. Okay, so I can take just the system stuff and modify that. I can take just the, now, some other cool things here. So let's go into edit mode and I'll show you what edit mode looks like. So edit, now change the prompt and put a bracketed edit mode. So the way you navigate this is hierarchical. So I would say edit, and then let's say interfaces. Now I drop down one more level, the interfaces. If I type show here, it'll show me everything set at this hierarchical level. If I type show pipe display set, shows me everything set at that hierarchical level in that easier to read, easier to work with set. As I go down, if I choose an interface here, so I could say edit, and go to the next level, edit, type. And then I could say GE dash 0/0/1. Now I jumped even further down. I could say edit unit 0. I've jumped even further down. You see how I'm jumping down every time I jump down the level, I can type in show, and it'll show me what's below that level. I could also type show pipe display set. Now, another thing that you can do here, because it's hierarchical, is I can jump. I can jump all the way up to the top level. So if I just type in the word top, I just jumped all the way back to the beginning.
Can you say bottom?
I don't know. I never said that because there wouldn't know where to go to where you really mean. But you could say, I could put it all on one line and jump all the way down to where I was and say edit. I can type interfaces GE 0/0/1 unit 0. And I can jump all the way there by doing it in one line. Okay. Now, let's make a change and then we'll see what happens when we make a change. So I'm going to change the address on interface 2. So I'll go back to the top, edit interface GE 0/0/2 unit 0 show. Now I see family INET. I say edit family INET. Show. Now there's the address. I'm going to change the address. I'll make it 192.168.20 instead of 2. So I'm going to say set address 192.168.20.1. And then we're using CIDR representation here for the subnet mask. And I type show. Now you notice it added it, but it didn't remove the other one. So I can have more than one address on there. Now what if I want to remove the other address? I would say delete address 192.168.2.1/24. Now I do a show again. And now only the address that I put in there is in there. So it will not overwrite existing information. Setting something doesn't unset something else. right? Now, how do I apply this? Because being in edit mode is like being in safety mode. None of this is taking effect to the box until I commit my changes. It's kind of like being in a Git without committing your changes. It's the same programming concepts that you guys use in your programming are what's used to operate this. There's a couple things you want to do before you, let's say, exit your edit mode and commit your changes. The first and most basic thing you can do is do a show pipe compare. And what this will do is this will show you what has changed and what has stayed the same. And this can operate also from the top level. So show pipe compare, and it shows it to you exactly the same way it showed it to me before, and saying I'm plussing the 20 and minusing the 2, right? Now the next thing I can do is I can do a commit, okay? And commit would actually write it to memory. I'm gonna type commit and question mark, show you all the commit things there are. So the most important thing with Juniper is you always run a commit check. What a commit check is it's kind of like a will this work type thing before I actually commit it. So do a commit check and it'll say commit okay. And then you can do a couple other functions. There's commit and quit, okay, which will commit the changes, put them in live, and then exit you back to that upper level show level where the prompt is different. You left edit mode. Commit at allows me to set a time. Let's say I want to commit it at midnight tonight. Okay. Commit comment, commit confirmed. Commit confirmed allows automatic rollback. So what a commit confirmed does is it applies your changes, and then if you don't reaffirm the commit again with a second commit, after 10 minutes, it rolls it back. Now, where's that? How's that helpful? Well, if this box is in Japan and I'm in South Florida and I'm the firewall guy making changes to a firewall in Japan, I certainly don't want to commit it and get locked out of the box after I make my change. So I do a commit and commit confirmed, and I know that at the minimum I'll only be down for 10 minutes. And then I'll confirm it if I get my prompt back, but if it pulls the carpet out from under me and I can't lose access to the box because what I did was not really working right, I get restored back to 0. The box itself will hold 50 copies of the previous commits. And then it also has another feature called rollback. So after you do commit something, you fully set it in the system, you can still issue a rollback and we'll take it back out. I'll show you that next. So the first thing we'll do is a commit check. See what it says. See if it likes what we put in. Okay. Missing statement root authentication, because we didn't set some stuff here. It's not liking that we didn't set it. So we'll go in and set it. So set system authentication. What do we want from here? Say SSH RSA. Plain text password. Now it wants a password. I'll just put a basic password in there. Okay, so now I'll do another commit check. So you notice that factory settings, it kind of gatekeeped me when I went to edit mode because I didn't set an administrator root password. So it forced me to do that before I could commit. Had nothing to do with what I was trying to do, but it has to do with the fact that the OS is so blank. It's like, wait, you haven't even set a password yet. So set a password before you get out of this. Commit, check. We should get a clear commit here. We'll see. Configuration succeeds. So we can do commit and quit. And that will commit the check, the configuration to here.
when you commit that, like saves it.
That saves it to memory, hard memory. So if I reboot the box now, the two things I did, was I hard set the password for the root account. When we log back out now, it's gonna ask us to log back in. And if I don't put that password in, I don't get in. I gotta factory reset this thing. Okay.
And then you.
Also,
said
I changed that IP
back.
address. Well, right now, I'm gonna show you that. So, show configuration. So we can see that root authentication has an encrypted password. Name server, blah, blah, blah. Those are all defaults. Then our interface should be down here below. Zone management. And there it is there, the 20. Everybody see that? So you can see that there are several commits, and then there was a rollback 0 and 1. If I make another change, 0, 1, 2, it counts up, right?
And you can select any one of those 50 you said is the most.
Yeah,
that'll-
50, so it'll do 50 previous changes. So if I do rollback 0 and then exit, then do show configuration, get down here to our interfaces. So it's still on that one. We do rollback 1. Edit. Maybe I didn't commit it.
Yeah.
It's now it won't let me out until I reset the password again. Because by rolling back to 0 or 1, the previous unwritten thing, I still have to set that password. Not a big deal. So we can say rollback 0. Commit. So 0 is your last commit. 1 would be the commit where
Oh, it's not 0, then 1.
it counts upwards. So your oldest one would be the oldest number. Your newest one is 0. So 0 is the active one you're running on.
Okay.
Right. It also starts at 0, and if it's 50, it only goes to 49. So it's 0 to 49 is 50 rollbacks.
Yeah.
But I could tell it, if I had 25 rollbacks in there and I knew that something was changed at rollback 16, I could say rollback 16, and it'll boom me back to 16.
Will take to the exact state you were on 16, right?
Correct. So that's something that Cisco has and doesn't have on their platform, not all of Cisco's platforms. So the two things here that Cisco doesn't have that Juniper does. Juniper has this safety net where the commands that I typed in edit mode aren't taking effect until I commit them. When you're in a regular switch or a router or a firewall with Cisco, the minute you hit enter, it's done. Okay?
They don't have any.
There's no commit,
Checks.
confirm, check, shit, no. Now, the upper level ASR, iOS XR, the super high level platforms, they have a commit system. But that only came out years after Juniper. So they all kind of copy each other. Good ideas go well, And so that's it for tonight that I want to show you guys about this thing. We'll show you that you could set the host name of it. That's a very simple thing to do. So if I said set host name, set system host name, and we'll call it CSC Firewall 1. And then I'll do a commit check. Check. Should be okay with that. Yep, I'll say commit and quit. Now what that'll do is that'll change the prompt. And it feels free to do it. And now it's root at CSC firewall 1. Now, if I came back in here, edit, show rollback, question mark. See, I have more than one rollback now.
Oh, yeah.
So if I roll back 1 now, and then I do a commit and quit, should lose that CSC firewall 1.
Cisco doesn't have this, they don't have a rollback feature.
Commands entered into Cisco interfaces and configurations are live. The minute you hit the button, it's in place. Well, that didn't go back to 1. Maybe I need to go back to 2. Oh, change it. Maybe that doesn't change because it's not, it's really agnostic.
About the address that you changed, shouldn't we be able to see a difference?
Depending on if it changed back. Because
That should be 2 instead of 20.
no, well, it's 20 now. If I set it to, let's say 30 and then roll back, it would go back to 20. It wouldn't let me do it from 0 because it wanted the password set at the same time.
Oh, okay.
You can kind of jump through these configurations, so. Okay, so now I logged out, so now I say CLI. Back in. Five. When's the earliest time? It would be 5, so go back 5. Now if I do a show, at this point here, even though I didn't set the password, thinking that address will be back to the, no, it's still at the 20. There, roll back.
Each time you do rollback, does that create another log?
Yeah, well, every time I do a commit, it changes, so it's, that's
Okay.
all.
Each time you commit to a rollback?
Well, each time so you issue rollback here, but each time I hit commit,
Yeah, okay.
I'm writing to the system to create a rollback. Anyway, you guys get the idea, right?
Mhm.
So. This is how you jump around the system. The next time, break this thing out, I'll show you guys how to set this stuff up here in the security tab. So like you can look at some of this stuff like show security. Set and what's set on the zones. Now, there's also other commands here. So you see these commands terse. Okay, terse is like a abbreviated format. Type would be to show information for a specific type of zone. But the detail is something that's built in. So detail will typically give you more information if there is more. So if I do show interface detail, I'm gonna get this long ass thing, every interface and all the settings for it. Okay. And this is the last thing I'll show you guys. So this is like all the crap about the single interface we're still looking at. Like now if I control C and break out of that, if I say show interface terse. This is like a go-to command for these things. This gives me a very abbreviated look.
And
What's here?
that's what terse does.
Terse abbreviates or shortens it down to just a summary.
Yeah.
Like a briefing. In Cisco, you'd call it brief. Say show interface brief. Show IP int brief. Here you're gonna say show interface terse. And that gives you that versus show interface detail. I can look at just one interface if I want. Tell it to anyone. Now keep in mind there are built-in interfaces here. So the ones that you saw versus the ones that are here, there's some automatic ones. These ones here are tunneling interfaces, VLAN interfaces. Brief is a option there. These are loopbacks. There's a loopback built into here. IRB is an inter-network routing bridge. So it's like a layer 3 interface. GRE is for tunnel. Then you have your physicals. And there's some other GR interfaces for tunnels and your GEs, your LTs, your MTs, your SPs. These are all different types of built-in interfaces. If you want to know more about that, go to Juniper website and look at the interface details, what these things mean. But there's a lot of what we call built-in logical interfaces. Everybody knows what a loopback is? If you don't, it's okay. I gotta know though. So you don't know what a loopback is. So loopback is a very important type of virtual interface inside of a system. So loopback is an interface that's built into the software that's behind all the physical ports, sits in the back of the router or the switch or the firewall. And it's there as a, it can hold an address, and each loopback can have a physical address. You can have more than one loopback in some systems. In other systems, you only get one loopback. In Juniper, you get one loopback, and that's this one here. But a loopback will always be up. So a loopback being this, back end address that's built into the system, and it's meant for like testing, or I'll give you another reason for it, but it's always going to be up. So loopback is always up. So you assign an IP address to a loopback, it'll always be up. You can hit that address no matter if the physical ports are down. Okay, well, why is that important? So in routers, when you're dealing with stuff like OSPF or RIP or any of the protocols for routing, you have to have what they call a router ID. So what you do is you build a loopback into the router, you configure it with an IP address, and then you assign that to be the router ID. Why would I assign that to be the router ID versus giving it the physical interface? It's always up. So the router ID will always be up, so the OSPF process will always be up. If I assign it to port G01 here, T01, whatever 01, the physical port is, and that port goes down, my routing process then goes down. And what it is when a router talks to another router or a firewall talks to another firewall, they exchange this information of router IDs. Okay. Every one of these things is a router in this case here. So if I did show route, there would be a built-in table here. Okay. And the table has a little bit of a key, and you can see that the table has, what's interesting about the table here is it did throw 20 in there, and it sees them all as local. So it only sees itself. But it's not, these are just static routes because they're static physically bound routes. If I turned on some type of routing protocol side of this thing, which I could do if I went edit, it says router, or that router, that protocol, that shows routing protocol, right? Yeah, something like that. OSPF's here. Yeah. Set a routing protocol in here, and now I'm talking that routing, and that would then create. Watch what I do here, because this is a top level thing. So This is something that hasn't existed on the system that I'm programming into it. So when I program a firewall, protocol OSPF, see if it wants anything else. It should just take this set protocol OSPF. We could just say area 0. Zero slash dash 0. Hit check. Now, everything there is on level. It didn't see any programming problems with what I did. I didn't leave anything hanging. So commit and quit. And what's going to happen now is I'll show you that what I entered in there wasn't in there before. When we looked at the default configuration in the hierarchy, show configuration pipe, display, set. You'll see that what I entered in the configuration has its own new section in here. Set protocols OSPF. But that did not exist before in the base configuration. But because you can turn on a routing protocol inside a firewall, I enable it, I wrote it to the config, I even put it in there. Now if I do a show route, it tells me, okay, a little bit that I'm turned on with OSPF. How do I know it's turned on with OSPF? See the last thing in there? 224.0.0.5, that wasn't there before. What is 224.0.0.5? Does anybody know? So the addresses from 224.0.0.0 through 240.0.0.0 are what we call multicast. Okay. 224.0.0.5 is the multicast protocol designated for OSPF hello messages. The way OSPF talks to other OSPF routers, it sends hello messages, say, hi, I'm this router, I'm here, this is what I know about. And the other router says, hi, how you doing? And if I don't get a hello message from you, I turn off. If I remove that set protocols OSPF area stuff, it's all gone. Notice I said area 0, but it wrote it as area 0.0.0.0. Okay. Also, this .0 here means I could have sub interfaces here. And I could have multiple IP addresses operating off of one physical interface as sub interfaces. Could also have them virtually as IRBs.
What's the point of having multiple?
So like to route between multiple points. So like to route between with multiple networks. So if I have 6 different segments that have to route through this interface and I don't want them to be physically going through the same interface to go in and out, I'd create sub interfaces. Like you'd be sub interface 10, you're 20, you're 30. Then on the other side, I'd have 10, 20, and 30. You talk directly to 10, he talks directly to 20, he talks directly to 30.
Is that a good way to put traffic in different locations?
Well, yes,
More in terms of traffic.
you're containerizing it to that sub interface. You're also able to then decide who goes first,
All right.
right? And who goes last. And, you know, so if you're the voice network and you're the real-time video network and he is the, you know, Instagram network, he goes last, you go second, he goes first. I have to set it up so that that's the way it flows. In the Cisco world, we have something known as VRFs. VRF stands for Virtual Route Forwarding. And a VRF is a virtual router inside of the router. So at the university here, we have multiple VRFs. We run a multi-VRF environment. So there's VRF data, and that's where most of the employees exist. And most of the data that we use for the help desk is on data. Generally, everybody who works here is on data on their computers. Then we have a VRF, you know, labs are on data, wired systems are on data. We have a VRF just for wireless. So all the wireless communication is segmented into a routing structure that doesn't touch the wired section. We run OSPF here, and using these VRFs along with OSPF areas, we're able to divide the wireless network from the wired network so that in order to get from wireless to wired, you have to pass through what's called an ABR. ABR stands for Area Border Router. So that negotiates between two OSPF areas. Our ABR here is the firewall. So the firewall that I just turned OSPF on here is area 0, that's the base area, is the ABR between any areas.
So the physical network here would be area 0, let's say, and the wireless would be area 1. Is that what you're saying?
Yeah, wireless, I think, is a higher number than that. I think 0 is the data, 1 is management, 2 might be voice, 3 might be wireless, 4, I don't remember them all by heart, which ones are which. But I know that we have probably about 19 right now, based on how I've cut up the pie. And you can consider that what we like to call the legacy network. So the original campus was divided up in that way. When I implemented what we call MPLS, or multi-label packet switching, we went to an enterprise environment that there's no more OSPF. We still have the VRFs, but we don't run OSPF areas, okay? Not until you get to the legacy side. So each building has all the data VRF and the wireless VRF and the voice VRF.
Oh, okay.
But when they're MPLS, they only route what's directly connected to them because they're all in one building. Now, understand wireless is a different animal because what happens with wireless is that the wireless network is tunneled between, it's open between you and your wireless device and the access point. That's the wireless network. Once you hit that access point, it's tunneled back to a controller over here, over management network. So you go wirelessly to that device is hardwired, and it tunnels you back to the controller. The controller is the end of the tunnel where you pop back out on wireless, and then go out to the firewall and go to Google, and then come back through wireless, go back through the controller, go back across the tunnel, and then you're back to the magic air connection that talks to your device. Okay, that's different than everywhere else that we do architecture, where you're in this VRF, you talk to your gateway, talk to the other gateway, you then talk to the firewall. There's no tunnel in between the other ones. There is an MPLS, it's kind of hidden behind the scenes and nobody sees it. And that's how we do the MPLS side. We can go over that another time. MPLS is enterprise routing. So if you're going to hack Verizon or AT&T or Comcast or any of the big boys, you want to know MPLS because that's how they play ball. It's with MPLS. And what MPLS does is it allows you to serve up multiple networks without caring about what your IP address is and what your IP address is. They could be the same. You're one customer, you're another customer. I still allow both of you guys to go through, and I don't care what you call yourselves. I put this overlay system in place, just takes your stuff and tunnels it back, throws it out the door, comes back to you, throws it back to you. You could be whoever you want. I don't care about who he is either. We know about RFC 1918, right? Everybody's heard of that one? These things should be like synonymous with your like lingo. RFC 1918 is the basic IP rules. It's an RFC, request for comments, by the IEEE for, and that's like a smug way of saying like, this is how we're doing it. RFC 1918 tells us how to run internal privatized networks versus public IP. So 192.168, 172, 10 are all privatized IPs. Okay, based on subnet mask, we'll give you the size of it. So 192.168 is typically a /24 network, and you can have 254 hosts, give or take. A 172 you can have is a /16. You can have about 65,000 hosts. And that's 172.16 the 172.30. There's a range of them there. Okay, we use them here.
That's the internal, private facing.
It's a private network on the inside. So the rules for private is that they're not routable on the internet.
Yeah.
So nobody in BGP internet will route a 192.168 or a 10 or a 172. But if you're a 10 and you're a 10 and I'm a provider, I take your traffic and I give you a public IP in front, you NAT to that public IP from your 10, and then I take it and I hand it off over here and I give it back to you. And I don't care that you're 10, I don't care that you're 10 because I use a different system and overlay to make things work. That orchestrates things on a much more stable environment than you, because otherwise, if you screwed up, you could hurt him. So MPLS containerized each of the buildings here, or the colleges, let's call them, and major facilities to their own environment. So if some dummy in the library messes up, causes a loop, okay, they'll take out the library, but he's not gonna take out the president's office. And vice versa, if someone in the president's office screws up, they'll take out the president's building and everybody there will know who it is because they all know each other in the same building. But he's not gonna take out the scientist in building 96 or the utility plant that's running the air conditioner. So that idea, and it's a security concept that we run, is to contain by segmentation. So the more you segment, the better control you have, the more stability you have. When you have one big open sea of things, more can go wrong and you can hurt him and he can hurt him. And a lot of protection mechanisms need to be put in place. What's to stop someone from going in the dorm and plugging in their own router and backfeeding DHCP? Anybody know? You don't think you could do that? I mean, let's say we didn't know any better and we plugged this thing in, but we used port 1. And we plugged it into our wall jack in our dorm room. DHCP is enabled on this thing and it's gonna start crapping out 192.168 addresses. Gonna hit that switch, hit that VLAN, start talking to everybody else there. What we have is we have a system of protection mechanisms placed in layer 2 and our switches called DHCP snooping. It's a thing that we have to set up on the boxes.
That goes on the switch.
That goes on the switch, that looks at the VLAN, that we tell it to. It says, if you see DHCP addresses come from anywhere but this direction, they go in the pale and that port gets disabled. Not forever, we typically do like 4 hours,
Why?
because that's like the timer. That's the max timer you can do if you do a timer.
Okay.
Also because like if you plug it in and you backfeed and you disable for 4 hours, then tomorrow, if you unplugged and plug something in the right way, it'll start working and you don't call us. But if you plug in and I disable you for good, then you're calling me to turn you back on. So having the timeout saves me from having to go fix you after you break yourself. Now, if 4 hours later you left your shit plugged in and you're still going and backfeeding, it's gonna turn you off again for another 4 hours and keep happening until you wise up and unplug it and plug it in the right way. And then your ticket will still come through to us saying you're not working, right? So that concept of protectionism is in place along with the segmentation.
I didn't know that. The only thing I knew about MPLS was you would put that to address or to have lower loads on your router for the addressing, if like between the provider edge and the edge routers.
That's part of it, yeah. So the table's smaller.
Yeah.
In this case here, we took OSPF out of the play. We segmented, I wouldn't say micro segmented, we segmented out to the building. Everything was in what we call collapsed core here before that, where everything came back to one central point. So if one guy screwed up, that could break everybody, could break the whole data center. Used to happen. Not under my watch, but somebody else.
Of course.
So I came from the outside, and so I came from enterprise. Where in enterprise, this type of nonsense doesn't happen. We don't have scientists in enterprise. The workers go home at 5 o'clock.
Yeah.
And you can do work after 5 on the network to make sure it's okay. Here, it's a 24-hour shop. People live here all the time. You know, we're constantly up. So it's a different environment. There's a lot more going on activity wise here for the most part. We don't have that. The office is closed from 5 until 8 o'clock the next morning. And if you messed up in corporate and you screwed things up, you'd get fired. Here, they kind of like, you know, shame you a little bit, but they don't really fire anybody.
Unless it's HIPAA.
Huh?
Unless it's HIPAA.
Yeah, so that is $10,000 a day for every violation that you have. And we actually, you know, so student health services had guys working over there and they weren't doing the right thing.
Mhm.
And they were storing patient data, backing it up on thumb drives and then putting it in their desk. That was their version of backup. That's a big no-no with HIPAA.
Oh.
And they basically got, you know, put out to pasture. And that started what's known as BRIC, which is the healthcare information network that Ryan runs.
Yeah.
And that runs over in 104, 71, Student Health Services, and BRIC is its own VRF. And BRIC has its own firewall segmentation, and they run VDI clients because they won't even let them run their own desktops because it's safer for them to have a virtual desktop that we control the whole environment for them
Yeah.
than to be able to have a local desktop. You know, they're very locked down. They don't get admin rights to their systems and stuff like that. You know, they can only do what they're supposed to be able to do there. And even still, it still becomes a problem because, you know, you could be the fanciest, tightest thing in the world. If some fancy doctor comes in, he doesn't care. He's gonna take your information on his iPhone and he's gonna text it to somebody.
Yeah.
You know, to his colleague, and that's a HIPAA violation, but they do it, you know, because they're life givers. They think they're above everybody else.
They have insurance.
Yeah, that too. The most difficult people to work with in the outside the IT world of the school, because the school's not really difficult, is if you work in healthcare. Because these guys think that they are bringing life to the world and think they walk on water, and it's a very demanding environment. If you leave here, graduate, and go work a security job somewhere in Baptist Health or one of these hospitals, you'll see what I'm talking about. It's very stressful because you're catering to like someone who considers themselves to be like a rock star. Okay. Now, that being said, they compensate based on that. You know, a better environment with the same amount of stress would be like if you went to go work to support one of the big financials. Okay, and you're supporting a trading desk of, let's say, 500 guys that are trading on the stock market. That's a nice place to be because yes, it's high stress. The systems have to be up, but at the end of the year, you get a huge bonus.
Yeah.
Okay. You know,
They're doing good. You get a fact check.
right. Exactly.
Yeah.
You know, there's profit sharing there that goes on that, you know. So like there's big time security roles at all the big banks and they're usually bonused out pretty heavily. And you guys know who Lex Friedman is?
Yeah, yeah.
So he was just talking to somebody who worked at Netflix. It was pretty interesting.
Navigation.
Yeah, so you heard that one?
Yeah, I watch him every day.
Okay, yeah, so that was a good example of like, you know, high level work being done at Netflix
Yeah.
and bricking the whole system and whatnot. It was interesting, you know, to hear his viewpoints. You know, and you guys should constantly be listening to guys like that because you'll pick up tricks and things in the field, even just terms that they say. If you don't know them, go look them up. You know, all the different things that they talk about,
Yeah.
you know, because they're introducing concepts. One of the things I learned early on, and it's kind of sucks, but the West Coast guys are, let's say, 3 leaps ahead of us. Okay, than everybody else in the country when it comes to tech. Silicon Valley operates at a higher level than the rest of us do.
I imagine.
So if you can get in like Discord groups and other like, you know, programming groups and other Reddits and stuff where you're regularly interfacing with them, you'll get you'll get a little bit of taste of what they're dealing with, which is again, 1 or 2 steps ahead of where the rest of us are, because it kind of trickles out from there to the rest of the country. That's just the way, that's where all the big places are. So that's like, you know, the Detroit of automotive, it's the Silicon Valley of computers, you know. that they're typically gonna be a couple of years ahead of everybody else. You know, bleeding edges, really.
And then they branch out to Texas, lower tax.
Texas is known as, yes, it's the Bible Belt, Texas. So Texas Instruments is what made Texas a very big place. I don't know if anybody heard of Texas Instruments. They make calculators these days. But they used to make computers. Yes, they made a lot of bigger electronics, and they were one of the original computer companies. I had a TI back in the day, it ran BASIC, and you could run programs on it, right? What was called BASIC was the programming language. You could write programs on it to do basic things.
I've used it.
Yeah.
That was the first language we were taught.
Yeah, this is very, very basic, very simple, you know, print my name,
Yeah.
loop, print my name 1,000
TLS,
times.
clear the screen.
So, but, yeah, so these days you wanna be, you know, more of a programmer slash security guy than just a security guy, you know? This is hardware security. What I showed you guys here is how an appliance works. It's a specific brand, has a specific set of rules, and once you understand it, you got it, you move on. I like Juniper because of the way that it shows the configuration is like programming. You are working on a Linux system and it is programming. As you can see, I put something in there that wasn't in there, and now it's part of the system. It's like you're building your own modules and submodules and stuff like that. Their policy options and stuff are something that you have to get used to because the terms, okay, kind of wordy, inside to outside, trust to untrust, from zone to zone. You know, and the older ones here, you see this screen stuff. Newer ones don't have that. They've rebranded it a little bit. It's just like anything else. You would download operating system upgrade for it and upgrade it. So one of the things with these things, you saw it in the beginning, if I exit, let's see, CLI, should show me, well, no. Show chassis. Where? So this actually it can be traced sometimes to a date. So you'll notice that this came out in 2016. Okay. Right now, we currently run like 2020, 22 dash something over in the back room. You don't always run on like the newest version, but each one of these numbers indicates a revision. Like this was built in the first quarter of that year, and it's revision number 45, D45. If you go to Juniper's website, there'll be a bunch of them there. Each one will have bugs and features that are in and out of each version, and you would read the release notes on it.
You would install patches for.
Right, so patches are sometimes known as SMUs, service maintenance upgrades.
Yeah.
Typically, in this kind of environment here, you would just overwrite this. In an environment where you have two routing engines, there's a little bit of a procedure. And what you do is you break the redundancy of the routing engines. You set the backup as the primary. You upgrade the primary. Then you flip to the primary. Then you upgrade the backup. Then you reset the redundancy. And that little 4-step act there is how we upgrade the back end in the back room there. And it takes, I would say, about 45 minutes when you get through jumping through all those hoops. But and we actually use a rollback. So like when you break the redundancy, you do the upgrades and then you just roll back and it puts the redundancy back in.
I have a question on that, like, what is redundancy in the term of networking?
So there's several different levels of it. You could have the term of hot redundancy, where I'm active. So I have two routing engines operating together and they're both active at the same time. And if one goes down, the other one stays as primary. Okay, and in our core routers here, we do that. We have what's known as SVLs or switch virtual links that are physical links connecting two separate boxes. One box sits here, the other box sits in building 96. They're wired together via 400 gig fiber links. And if we turn this one off, that one takes over. Okay.
Like hardwired Through the buildings?
They're hardwired through the buildings over fiber optics, yeah. And that maintains a back channel for redundancy. That's separate boxes acting as one solid unit virtually. Switch virtual link, it creates a virtual link. In the data center world, we do the same type of thing. And we'll have a, what they call it, a peer link in Nexus. You have a peer link between two peers. Part of that redundancy allows you to do something known as MC lag, which is lag is link aggregation. So port channeling, anybody know the term port channeling? So I could take two of these ports in this world here. Let me see if it has the capability. So if we see something in here known as AE, see it. Set interface AE 0. Yeah, it'll do it. So AE, say unit. So far, family. Find that. Okay, commit. I'll do a commit and quit without doing test box. Without doing the check. It might kick it back because it does have a safety net. Like if it really doesn't like what you said, they'll be like, I am not doing that, you know. But most times it'll take it, especially when it's just logical stuff like that. So AE0 stands for aggregate Ethernet, which means I can take two ports now. And so if I do a show interface terse now, I should see my AE0 in here now. Find it. There. Show configuration. It should show up here though. Yep, there it is there, A0. So that's a virtual interface, and I can then group physical interfaces onto the virtual interface. Typically you would do them in pairs. And that gives you the ability to port channels. So if I have, let's say, a server that has two NICs on it, I can port channels to those two NICs to the switch so they're bonded together. Okay, does that make sense? So if I have two 25 gig NICs and I bond them together, I got 50 gig back channel bonded together. So you can typically port channel like up to 8, sometimes even more than that on a device. Port channels can go higher. What happens is you deal with something called serialization when you deal with port channels. Serialization is where I'm sending TCP stream to you over the port channel. Has it know to go over port 1 or port 2 of that port channel, right? So there has to be a formula as to what flows go over this one versus when I go to the second link and load balance. Certain things will go back and forth. Certain things will go through only the right side and not the left side. It's kind of wonky when you do that, and it can cause problems. When we set up the switch virtual link between the two switches for redundancy with the 400 gig links, we set up port channel. It's one that's not touched by the system. It's used in the back end of this SVL, and it builds a bridge and it controls it. When you do it with PeerLink on like a Nexus data center platform, it's the same thing. So the redundancy we talked about just now on every level that I just mentioned is hot. So both links are up, both things are up, both things are active. Then you have hot standby, we'll call it. So hot standby means I'm active, I'm the boss, you're sitting in the background waiting for me to fail, and if I fail, you take over. Okay? So that's another way of doing things. The firewall, FortiGates, they run in a hot standby. Now, remember we talked about very early in this discussion about forwarding plane versus control plane. So the control plane in the firewall operates in an active standby mode, but the forwarding plane operates in a hot mode. So ports because they're separate, I can do two things at once differently. So my forwarding plane on the firewall and the ports on this side and this side are both active. Even though, and I'm sending traffic to both, but I'm kind of only listening over here. And then when I fail over, because I lose this side, he starts listening immediately. But the control plane sits over here and he doesn't move to over here unless he's gone. And then you're operating out of this side now. And if he comes back, if he reboots and comes back to life. Now, why would these things reboot and come back to life and why would they have a problem? You guys have heard the term of memory leak?
Yeah.
Memory leak.
Memory leak, yeah. So memory leaks happen on these devices where code, poorly written code that's running the back end of the device will cause a memory leak, and over time, internal memory of the system will get overloaded, and then it'll crash and crap out. It's software-based problem that happens with poor coding. So when you're dealing with something that can do so many different things like a Swiss Army knife, and there's so many iterations of code that have been put in to get to that point, there's a lot of bugs that come along with that. This is a generic device. It doesn't matter if we're baking cupcakes or if we're an automotive center or if we're the FBI. We might be using this device in the same device in 16 different ways. Okay? It's able to do that, but it doesn't do them all great. Sometimes one of them is going to go sideways. So memory leak is a common thing that can happen in these type of devices due to poor coding. This is why Juniper is preferred over Cisco, because what's the underlying system of the Juniper? BSD. What do we know about Linux versus other operating systems? Is it known for its stability and its ability to stay up? And it's very hard to break versus other operating systems, not so easy. I think we'll cut it for tonight because we're getting over the time. So we can continue this next time if you guys found this beneficial. I can even bring in other topics and other devices. Anybody else have any questions?
But this is, so Cisco doesn't run on, Linux?
BSD? No. It runs on a variant of an OS that was written from a previous company. Cisco's operating system was bought